Hi there. For this video, we are tasked to find the number of n integers that would satisfy the given inequality. So the first thing that I would do is I would square every term in the inequality so that we can remove the radical sign inside. So we have out here 2010 squared is less than n times n plus 1 is less than 2016 squared. Now observe that we can actually write 2010 squared as 2010 times 2010 and 2016 squared as 2016 times 2016. So bringing down the inequality. So we have this inequality now. The reason that we did that is because the form of this one is now, and this one is now similar to the one inside. Since we can view this as n times n, this one is n times n. So we can now easily obtain the values of n that would satisfy this inequality. So first, clearly if we take 2009, then this inequality inside becomes 2009 times 2010. Which does not satisfy the inequality, since this one is actually less than 2010 times 2010. So, and actually the same goes for all integers, all positive integers less than 2009. Less than or equal to. So we don't look at those cases anymore, and we start with n equals 2010. If n is equal to 2010, the inequality inside becomes 2010 times 2011, which is in our inequality, since we can view this one as this part and this one as this, so it's beyond that. Aside from that, we also have n equals 2011. So we have 2011 times 2012. So that is the inequality inside, which is also in our inequality. And we do the same for the rest of the possible values. We also have n equals 2012, since that would yield us 2012 times 2013. We also have n equals 2013, since that would yield us 2013 times 2014. We have n equals 2014, since that would become 2014 times 2015. And we have n equals 2015, since that would yield us 2015 times 2016. What if we take n equals 2016? Then our inequality inside becomes 2016 times 2017, which is not part of our inequality, since this one is greater than 2016 times 2016. So it's around here. So that is not part of the inequality that we want. And actually, the same goes for all values greater than or equal to 2060. Now the question is this already the number of n integers that we have? Well, we could actually take also negative values in here. Since if we take out here n equals negative 1000, then this one would become That would become negative 999. Multiplying this would still give us a positive value, which means it could still possibly satisfy our inequality if we chose the right numbers. So we can actually take n equals negative 2011, since our inequality would become negative 2011 times negative 2010, which is simply 2010 times 2011, since we can cancel out the negative sign, since negative times negative is equal to positive. So we have found 1. And actually the same idea applies to the following n values, negative n values that we will find. So we can also take n equals negative 2012, since that would give us negative 2012 times negative 2011, which is just 2011 times 2012. We also have n equals negative 2013, since that would give us negative 2013 times negative 2012, which is 2012 times 2013. Then we have n equals negative 2014, since this would give us negative 2014 times negative 2013, which would give us 2013 times 2014. Then we have n equals negative 2015, which would give us negative 2015 times negative 2014, which is simply 2014 times 2015. Lastly, we have n equals negative 2016, which is negative 2016 times negative 2015, which is simply 2015 times 2016. Now observe that if we take a greater value than negative 2011, say negative 2010, then our inequality becomes negative 2010 times negative 2009, which is equal to 2009 times 2010, which is again not part of our inequality, similar to how we showed it in the first one. And if we take a lower value than negative 2016, say negative 2017, then the inequality inside becomes negative 2017 times negative 2016, which would give us 2016 times 2017, which is again not part of our inequality as shown previously. And the same applies for bounds greater than or less than to that one. So indeed, these are the only possible values of n that we have, since we have already explored we have already explored the positive and the negative signs or versions of n. So that's it for the integers, since integers, the key in integers is simply positive and negative, since we can't really take fractions or rationals or even irrational ones. And so we count this one. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So in total, we have 12 integers that satisfies the given inequality. So that is the answer for this problem. So the key is that first, we can manipulate the inequality into this form out here. And from there, we could easily obtain the values of n that satisfy the inequality. But after getting this part out here, after getting this one, we need to take note that we also need to take the possible values of n that are negative, since we are dealing with integers out there. So take note of those key points, and we could easily answer these types of inequality problems. So I hope you enjoyed this video. Feel free to comment down below any comments, clarifications, suggestions, or even your own solution to this one. If you have a better one or even a longer one is accepted, just feel free to share it and don't hesitate. So yeah, I hope you had fun in this video, and that's it for today. That's all for this video.